Changing majors. Data were collected from a survey given to graduating college seniors on the number of times they had changed majors. From that data, a probability distribution was constructed. The random variable x is defined as the number of times a graduating senior changed majors. It is shown below. The possible values for x are 0, 1, 2, 3, 4, 5, where 0 indicates that they did not change their major. 1 indicates that they changed majors once. 2 indicate they changed their major twice, and so on. The table also lists the corresponding probabilities. What is the probability that a randomly selected student change his or her major at least one? First, we write it in symbolic form. The probability that a randomly selected student change his or her major at least one. Remember that x represents the number of times they change their major, and so at least one is the event x in symbolic form greater than or equal to 1. At least 1 meaning 1, twice, 3 times, 4 times, 5 times, and so on. Each of these values or outcomes are disjoint, so we can add these corresponding probabilities, but when we deal with at least one, there is a better way to find their probability, and that is when we use the complement rule. The probability of at least one is 1 minus the probability of none, and none is when x equals 0. And so this is 1 minus 0.28 or 0.72. Part B. What is the probability that a randomly selected student change his or her major at most twice? At most twice, meaning the maximum is 2 times, at most twice. And so translating it, this is the same as finding the probability of 0, 1, or 2. And so again, at most twice. The maximum is 2 times. So this is the probability of x less than or equal to 2. And this is the probability of x equals 0 plus the probability of x equals 1 plus probability of x equals 2. There are only 3 cases where they change their major at most twice. The corresponding probability for x equals 0 is 0.28. Probability of x equals 1 is 0.37. Probability of x equals 2 is 0.23. Added these 3 numbers, we have 0.88. Part C, given that a randomly selected person did change majors, and so this is a conditional probability. The probability itself is what is the probability that he or she changed major more than 3 times. So this is strictly more than 3 times. Strictly more than. However, with the condition that they change their majors. Now, this is the case when they change their major either 1 time, 2 times, 3, 4, or 5 times. So this is x greater than or equal to 1, where the first event, x greater than 3, is event A, and the second event, x greater than or equal to 1, is the event B. Using the conditional probability formula we have, this is the probability of x greater than 3 and x greater than or equal to 1 divided by the probability of x greater than or equal to 1. Now from the table, we see that the intersection, or what the 2 events A and B have in common, where x is greater than 3, so that is 4 or 5. That is when x is greater than 3, 4, or 5 only. And x is greater than or equal to 1, where 1, 2, 3, 4, and 5. And so what these two events have in common is 4 and 5. And so the probability that we would use in the numerator is 0.02 plus 0.01. And in the denominator, the probability of x greater than or equal to 1 is the probability that they change their measure at least once, which we found in part A, and that number is 0.72. This is 0.03 divided by 0.72. This is 0.04166667, and if we round it to two decimal places, it is 0.04.